genetic excellence. Only one layered genetics company can claim this title. Only one has proven innovation and determined resolve to continuously select the next generation of birds best suited for the world's egg market. Only Highline. We are committed to invest in the long term while achieving as much genetic progress as possible for our customers in the near term. As a genetics company, each day is a gift to achieve genetic progress for our customers to attain increased profitability. And we are accomplishing this. Generation after generation of Highline layers have higher livability and produce more saleable eggs on less feed per case of eggs. Highline International is not only the world's oldest and largest layer genetics company, but is the industry leader with a global yet local presence. We have a substantial responsibility to supply the world with top-performing layer genetics to feed a growing population with an inexpensive and nutritious source of protein, the egg. Meeting the future with confidence. Highline geneticists have made the genetic engine more powerful and efficient. We have narrowed the scope of genetic traits we analyze and ultimately use to select the next pure line generations, with the goal to achieve increased egg numbers, longer persistency of lay, optimal egg quality, the most profitable egg weight profiles, and feed efficiency. Our worldwide production capabilities in the USA, Europe, Brazil, and Southeast Asia ensure a stable and reliable supply of high-quality chicks for our customers. Highline believes in the value of giving customers access to exceptional technical expertise. Every day, our team of global and local specialists, nutritionists, and veterinarians help customers achieve the best performance from their Highline layers. The comprehensive breeding program encompasses all aspects of bird health, well-being, and performance, resulting in a well-balanced bird capable of performing in multiple commercial environments with high livability that can produce high-quality eggs with great efficiency. These improvements, combined with local technical service and sales support, a team of veterinarians, pathologists, nutritionists, microbiologists, poultry husbandry specialists, and an excellent network of distributors, secures Highline's commanding presence as a world leader in layer genetics for our customers for years to come. The future is bright with Highline. Superior genetics, unmatched customer service, innovation for the future.
Hello, my name is Jonathan Cade, President of Highline International. Sustainability is a fundamental value of Highline and drives our daily quest to develop the world's most efficient, productive egg-laying hens. Throughout our organization, we strive to leave a better, more healthy planet for the next generations while helping to feed the world today.
My name is Danny Lubritz, and I'm the Director of Research for Highline International. Sustainability is in our DNA at Highline. Since our inception, Highline geneticists have been committed to increasing rates of lay while decreasing feed consumption. We feed more people today due to increased egg yields per kilogram of feed. This improved efficiency reduces the demand for cropland and cuts down on our greenhouse gas emissions. Highline is determined to reduce its carbon footprint and is committed to helping our customers do the same.
I'm Eduardo de Souza Pinto, and I'm the President of Operations for Highline International. In order to produce the highest quality breeder chick as efficiently, humanely, and sustainable as possible, we are dedicated to drawing on fewer local resources and less energy usage. We continue to explore and develop new renewable and cleaner energy sources while giving back to the planet.
Insight into your flock performance is critical to reach maximum genetic potential and profitability. Vision Egg, Highline's flock performance benchmarking program, identifies opportunities for your flocks with action items for improved layer performance. When you confidentially send us your flock records, we compare your records to more than 200 million layers in our database. Your Highline representative will review the report and provide recommendations for improved performance and bird health. This program, analysis, and assistance with implementation of the action items is complimentary for our customers. Vision Egg is yet another way Highline's global but local teams go above and beyond to partner with our customers to achieve the best results with their Highline varieties. Get the most from your flocks with better birds, better support, better experience, and better results. Contact your Highline representative today.
It is my privilege to be sponsored today by Highline International, provide you with a presentation on the importance of drinking water quality for layers. I'm Dr. Susan Watkins. I'm a distinguished professor emeritus, retired from the University of Arkansas System's Division of Agriculture, Center of Excellence for Poultry Science, where for many, many years I was able to focus on drinking water quality for turkeys, layers, broilers, breeders, and I was able to compile a lot of good, valuable information that I hope I can share with you today. When we think about water quality, there really is a limited amount of research done in this area. For one, it's kind of difficult to evaluate water in poultry production in a controlled situation. Work done by Brian Fairchild looked at iron, a few others have looked at some different things, but there's just not a lot of work done out there. And there's just far more nutritional studies done versus working with water because feed costs money. Water is typically free. So why are we worried about it? The last significant focus was done in 1971 by the National Academy of Sciences, and they did an excellent job of compiling an extensive literature review on the nutrients and toxic substances in water for livestock and poultry. I still rely on this book to some degree, particularly for things like the heavy metals, lead, arsenic, copper, those things that there's just absolutely nothing known about when it comes to poultry. And there was some work done in the 1980s, but once we had the introduction of nipple drinkers in 1990s and we had a significant amount of antibiotic use, well, the focus on water quality kind of went away. It just was put on the back burner. We didn't worry about it. But now times have changed. We're going back to open production facilities for table eggs. We're challenging these birds with a less controlled environment. We're using less antibiotics in the production. facility. So, and this bird has become very efficient, and as it becomes more efficient, it may be less tolerant to insult. So, because of these things that are changing, maybe it's time for us to revisit water quality and make sure that we're getting it right. We're not costing us performance in ways that we're over. So what I have learned about water quality over the past few years is really our birds are still very tolerant of most mineral contaminants. Sodium and chloride are the exception to the rule. We start getting over 200 milligrams per liter, which is also the same as parts per million. We're going to start to see looser droppings in the birds. We might even begin to see some eggshell issues if we start getting over 400 milligrams per liter. Depressed weight gains also increase feed conversions. This is actually a fix that can be managed through reformulating the salt level in the feed, or you can use reverse osmosis for salt removal from the water, although it has a significant waste stream associated with it when we start removing salt from the water. So you have to think about that very carefully. Iron and manganese, these are two other nutrients that tend to be very prevalent in water supplies, but the birds are very tolerant of those. We've seen water that was orange or black, and the birds could care less about it. What they are not tolerant of are the microbes which utilize these minerals, things like Pseudomonas, E. coli, Salmonella. When iron and manganese are present in the water, these nutrients can thrive and can allow microbes to thrive and cause challenges to the flocks. Calcium hardness, again, the birds are fairly tolerant of these minerals in the water, but what are not tolerant are our pipes, our drinkers, our cool cells. As we get scaling of these minerals on the equipment, we're going to get restrictions in airflow, water flow, and those are challenges for us. Magnesium sulfate combinations, we start getting over 250 parts per million sulfates. We're going to see some loose droppings. May need to deal with that. Alkalinity is one that we don't completely understand, but we know that some aspects of alkalinity put bitterness to the water, and the birds will self-restrict. Bitterness is one thing that nature tells birds is not good for them, so minimize how much of that you're going to take in. Acid water, or this low natural pH water, this water contains no buffering minerals, and you're going to see birds actually self-restrict on that water. So we need to add what I call clothes to the water, the contaminants that are dissolved in it, so that this water is not physiologically impacting the birds. One other thing I have learned is there's no perfect pH. We get sold all the time different concepts about what the pH should be, but really the pH of the water that's appropriate for your flocks is going to be alkalinity and acid dependent. So if you don't have a lot of alkalinity in that water to buffer it, then you're no longer drinking Coca-Cola to 3.2, you're drinking battery acid, and it needs that buffering capacity to make it palatable. Same with alkalinity. If we have a tremendous amount of alkalinity in that water, then we're not going to be able to do much with the pH using organic acids. We end up going to adding a lot of acid. It's going to be expensive, and we're going to make a water that the birds don't care to drink, and we're not going to achieve our gut health goals, if we will. So we have to understand what's going on with that water in regards to alkalinity, what's dissolved in it, so that we can make appropriate choices for the chemicals that we put in that water. What I have found in my career is the most significant thing we need to focus on with water is waterborne pathogens. And why I say that is water's the perfect carrier of health challenges. But so many times people tell me, well, I'm drinking the same water as my flocks and I'm not having any troubles with it. That's just not true, because poultry drinking systems change how water is managed versus how human distribution systems manage the water, because these poultry drinking systems are easily contaminated. The water's slow moving. It's warmed at times during the production facility. It may sit stagnant in the lines at night when the lights are off. The water lines have a lot of pinch points, hiding places that can harbor growth like Pseudomonas, on and on. And water often contains food that organisms need. So when we start having, again, iron, manganese, and also sulfur, we're providing key nutrients for several pathogens, again, like Pseudomonas, E. coli, coliforms, even Salmonella. So we've got to be cognizant of what's in that water. And then, of course, we inject nutrients into the water. This is not something we do in a typical household. We're going to be adding vitamins, vaccines, organic acids, probiotics, lots of different things that can have a huge impact on the quality of our water. So what do we need to do to get started with a good, sound water program for our flocks? Well, first we want to implement an assessment program. And that just boils down to inspect what you expect. Get out there and look at it. Go to the source. Changes. Was there work done? Have we replaced the pump on the well pump? And how does it look? How is the well housing structure? Is it in a dish, or is it sit up above the ground so that water can't leach down into the well from the surface? Storage. Is it clean? Is it clean? Do we ever clean our storage tanks, or do we allow a lot of sediment to build up in it, which then becomes a food source for pathogenic organisms? Distribution pipes. How old are they? Have they ever been cleaned? Can you even get a pencil into that distribution pipe because of the mineral buildup that might have accumulated over time? Injectors. Are they working correctly? Do they meet demand? Water system sanitation. Are the system clean between flocks? Are sanitizers used? Are products injected in a clean manner, or do we get a little careless with how we put things into the water? And then what products are we using on a daily basis? Are we using a lot of therapeutic things in our water that could be altering the quality of it? These are the questions that we need to take a good hard look at when we're creating a water program. Go inside the water system. These little inspection cameras are great tools to see just what does it really look like inside. Does it look like this? Extremely clean, a little bit of biofilm on the inside of that regulator, but for the most part, they've done a great job, versus some water systems we've put the camera into and they were just full of biofilm and material sloughing off the walls of the water system. Might not be a problem for the flock, but is it really worth that risk? Key point that I have learned: do not assume water sources and poultry drinking systems are acceptable. Monitor to confirm the quality. And we want to look at the source and make sure those are okay. Sometimes they're okay, sometimes they're not. We also want to go out into the barns and collect water from the poultry lines, drinking lines, and assess there to see what is the quality. I consider acceptable levels less than 10,000 colony forming units per milliliter of total bacteria. We don't know if total bacteria is good or bad unless we do an extensive assessment on it. That's a lot of time and money. So we just kind of make a one size fits all. Look, we start getting more than 10,000 CFUs, then it's time to take action to reduce that with some sanitation. I also believe that we should accept 0 coliforms or E. coli in our water supplies for our poultry. They just do not tolerate these well. And if these are present and we give them the right conditions, 1 E. coli can turn into trillions in 24 hours. So maybe an insignificant problem today could be a horrendous problem tomorrow. So send your folks out there, get some water samples, look at them, compare them to source, end of the line. Just a quick visual can give you an idea. Are you losing control of your water quality? In our antibiotic-free range world, we need to think about the therapeutic products that we're using and how they might be impacting quality. This was an operation that I visited that was struggling with some cocci challenges and some young flocks, and they were using some different products. And looking at the droppings, I was just kind of wondering, are things going well here? And the conditions of the barn, the air quality, the temperature, those things were right. So I said, well, let's take a water sample and just see what's going on. So we were able to do that in different farms in this operation. And we were finding things like the E. coli, Pseudomonas, staph, strep, Klebsiella. This is a pneumonia bacteria. So lots of different things were being allowed to thrive in the water systems because they become so focused on one aspect of the bird's health that they were overlooking the things that water could be contributing to their health challenges. This was valuable research done by Ken Macklin and Josiane Brown down at Auburn and a grad student, where they actually introduced infectious laryngotracheitis vaccine into water systems that were dirty with a biofilm. And then they were able to find up to 3 weeks later, this LT vaccine still attached to the biofilm. And so they used some different products to clean the system, to help clean it out in order to remove that. So kind of the take-home message here is, if our systems are dirty and we're using vaccines, are we creating an opportunity for that vaccine to remain in those systems and then not necessarily be given to the birds when we choose to give them? So it's very, very important for our vaccination program that we have clean water. Speaking of vaccination programs, in our layer industry, we do use a lot of vaccinations. So it's important to think about, how is the vaccination program managed? I would like to stress the importance of avoiding skim milk vaccine stabilizers. Some of the highest, and I mean in the millions, colony forming units per milliliter bacteria counts that I've ever cultured was in water that contained vaccine with milk stabilizer product. It had been left overnight waiting for the birds to clean it up, and it just became a cesspool that was infecting those birds with some gut health issues going on. Milk just contains the nutrients many microbes will readily use, so let's not give those potential microbes those nutrients. I recommend the sodium thiosulfate-based stabilizers. These neutralize any residual chlorine without adding the food. I also encourage you to think about, is your water system at risk of pathogens when sanitizers turned off? If it is, if you have a water supply that is contaminated with coliforms and you just can't get rid of it, maybe you need to use something like an ultraviolet light as a continuous disinfectant for that water. And that way, if you are using sanitizers with residual and you have to turn them off, you have a backup plan to help make sure that water is good quality go into those birds. And in the ultraviolet light, it doesn't have to be neutralized. So it's going to be point of contact, the water passes through, it's clean. Now it has the potential of being recontaminated, but we're gonna take that risk during our windows of vaccine and then maybe get back on a daily sanitizer program. Verify the pH. Again, pH is too low or too high, it's going to denature your vaccines. So make sure that you're not accidentally running organic acids and getting the pH to 4 or 5 while you're using a vaccination program. Or if you have a pH of 9 naturally occurring in the water, you may need to figure out a way to neutralize that with citric acid or another acid product in order to maintain the viability of some of these fragile vaccines, particularly things like bronchitis. Verify your injection technology. Here is an area where I have found many times on operations it was the root cause of production challenges because someone was just overlooking the injector and its ability to do the job properly. So verifying that this injector can actually manage the gallons per minute flow required for flocks, or the peak demand, if you will, and verify that it's actually injecting the proper amount of product per liter or gallon of water, and make sure it's not restricting flow. Another technology that has been rapidly adapted in the US is the peristaltic pumps. But these tend to just drop things on the water stream. So if you're using acids and you're using peristaltic pumps, you're going to get swings in your pH. It's 1 minute maybe high, 1 minute it's low, and it, irregardless of how many bends in the pipes you have, it's a river and it just flows through those pipes and it doesn't mix. So if we're using peristaltic pumps, we're trying to do acidification, chlorination, probably need to separate those pumps, add one product, get it blended with a mixing chamber before we add the second product. If you're using chlorine and acids, you could be fighting each other by gassing off your chlorine with slugs of acid hitting that chlorine. Line swab procedure. Here's an excellent tool to identify the biofilm in water systems. And because sometimes drip samples may not reflect the biofilm load present. So we want to go inside that water line and actually swab it to determine how much is living in it. I highly recommend using a swab that's a hydrated sponge or something with a lot of surface area that's wet, that can really wipe the inside of that line versus a culture swab Q-tip. Because when we did some work on an operation where they had we're working on the water line leaving the holding tank, and it cut it in two, and I said, well, let's swab inside there. And when I swabbed with the sponge, and then we streaked it here on this dish, the vat had swabbed with the Q-tip first and streaked it here. This was at 5:30 at night that we did this culturing. By 7:30 the next morning, look how much Bordetella was growing on that plate. Hardly any colonies were showing up on the Q-tip swab. So if we were only looking at these results, we would say, well, the system was clean. Whereas reality, we needed a sponge that was really wiping that biofilm out of there in order to determine, to let us know it was loaded with the pathogen Bordetella, and that system needed to be clean. Swabs can be just a great tool for looking at things like bacteria, yeast, and mold. And this was just across a farm where they weren't getting much out of the drip samples. They were using a sanitizer. Nothing much was coming out of there, but the biofilm told a different story. It said the systems were contaminated and really needed to be cleaned out because, again, this amount of biofilm is present, and we're having to roll off that sanitizer for vaccinations or whatever reasons, it creates a potential risk for our flock. We want to do a water mineral analysis, and what I recommend is the pH, and then the minerals including sodium, chloride, iron and manganese, calcium and magnesium, hardness, alkalinity, including bicarbonates if you can, nitrates, nitrites, sulfur, sulfates, silicon, and then the heavy metals. For our flocks that live on farms for many weeks, we're going to have a greater risk with the heavy metals because that's going to be a chronic insult to those flocks. So we want to know, are these present? Do we need to deal with them? And again, some issues just have to be fixed to prevent production challenges. This was an operation that struggled for several years, could not perform, did a water analysis, found that the water was very high in sodium and chloride, put in a reverse osmosis system, cleaned up the water, the farm performance went to the top of the company. Hardness, alkalinity. This is your calcium, magnesium, and birds are very tolerant of these minerals. Given the amount of calcium in a layer diet, 250 parts per million is very insignificant in the water. But where we need to be worried about these minerals is when they begin to deposit on equipment and pipes and start sealing them up or causing drinkers not to perform properly. Alkalinity refers to the amount and types of chemicals that can shift the pH above 7, usually expressed as calcium carbonate. It also can be dependent on the bicarbonate levels and sulfate levels in the water. And again, as I mentioned earlier, poisons in nature typically are alkaloids. And these, can back the birds off the water supply. Water systems must be cleaned right, but what does that involve? Well, in this operation, this line was cleaned with an acid, citric acid. Of course, it should, clean the lines. It says on the package it's a line cleaner, so surely it works. And then across the barn, there was a line that was cleaned with a 3% solution of a 50% hydrogen peroxide product. Both lines were left overnight, and then the next day they were flushed. And if we saw this water coming out of that line, our first response was, well, that line wasn't very dirty at all. Look how clean that water is. The real story is that acid went right past that biofilm, that material that was built up in the line, and didn't even touch it. It took a product that was designed to actually clean this biofilm, this debris out of the system, in order to start removing and cleaning it. So we've done some evaluations over the years, and I've showed this slide many times, and I will continue to show it because I think it puts it in perspective what we need to be thinking about when we're line cleaning. So if we don't do anything, material doesn't just go away on its own. A 3% bleach solution, that's 30,000 parts per million chlorine, did not necessarily kill everything that was in that water. And you certainly would not want to use this amount of bleach in a drinking water system because you're going to be asking for some issues with that system, some damage. Citric acid, again, it is not a line cleaner. It might help us descale if we can get that pH below 5, but it is not a line cleaner. Products like the 20% peracetic acids, 2% solutions, left 4 to 24 hours do the best jobs, as well as the 50% hydrogen peroxides that when we get those 3% concentration solutions. 1% solution, which would be a little bit stronger than what a medicator could inject in at 1 to 128, is not an adequate line cleaning solution product. So water line cleaning essentials. Right concentration of effective cleaner left the proper amount of time is key to success. Improper cleaner concentration, not leaving it long enough, that's both failures to the process. And I know you don't accept failures in other areas of your process, so don't accept it here in water line cleaning. 1 to 128 injectors, they may not be an adequate concentration. So we need to come up with injectors or submersible pumps and drums of solution in order to get the right concentration. Clean the whole system, water lines, standpipes, regulators, the distribution pipes from as close to storage and source as you can, all the way down to the last drinker. I get asked all the time, what products do I recommend? Well, I recommend the product that works for you. There are lots of great products. Document which one works best. Collect swabs pre and post cleaning. So before you clean, swab some insides of some lines to see how dirty they are. Do your line cleaning procedures and then find some different lines and swab inside those lines post-cleaning and compare the results. If you get a significant reduction, 90 to 99% reduction, you found your product. If the numbers go up or remain the same, you need to look elsewhere for what you're going to use. Flush the system post-cleaning with sanitizer the birds can drink. This is very, very important. In fact, a couple of weeks ago, I saw a great example of why we need to be doing this. And it was an operation that had cleaned their water lines, started a new flock of breeders, and they were struggling like crazy, and started swabbing in the water lines and found a new growth of Pseudomonas biofilm. So they had cleaned the system, removed the stable biofilm, and then just flushed in either a low level of sanitizer or no sanitizer and allowed the Pseudomonas that was somewhere in this distribution system to repopulate the system. And then that was a new challenge for those flocks. So we want to reduce the risk of pathogenic biofilms. And how we can do that is making sure there's a good level of sanitizer in that water coming in after we have done the line. So after the birds are gone, flush the lines. Power flush is best, but any flush is good. Remove the sediment, free-floating microbes. That's just going to remove anything that we don't want to waste our cleaner on. Make sure the standpipes are working. Prepare the product. I recommend adding a dye to it so that you know when the lines are completely filled with the product, and then you know when the lines have been completely drained of the product. So fill the lines with the cleaning solution. Activate the drinkers to get solution into the drinkers. I know this is just a horrible challenge for cage facilities, but sometimes we just got to step up and get that done and clean it. Maybe you need a little shot wet vac to suck it out and go through there, something to clean it out if you have to afterwards. Leave it adequate length of time, whether that's 4 hours, 24, 48. Some even leave their 50% hydrogen peroxide solutions, 3% concentrations, 72 hours in their water lines in order to make sure it's completely cleaned. After we have removed the slime, the biofilm, now if we have mineral challenges like iron, manganese, calcium, magnesium, we're going to use an appropriate descaler. And what that means is we got to have a product that won't damage the equipment, but can get that pH below 5 to dissolve that hardness mineral buildup. Again, recommend adding a dye to waterline cleaning products to ensure it is completely removed or completely added to the system. And it's just so easy to see that visual of that dye in the water. The lines in barns do not fill or drain at the same rate. So if you're using a standard amount of time to drain each line, it may be adequate, it may not. Visually knowing that that water is free and clean of the concentrated cleaner can save you a lot of headache. Again, even best products are challenged under heavy organic load. So here was an operation cleaning with the 3% solution of a 50% hydrogen peroxide. They had a lot of bacteria in the water prior to cleaning. Left the product in the water 48 hours and then just flushed plain NO water. And they were very surprised to see all this bacteria that they were collecting in the drip samples. Well, I'm not surprised. If we have a heavy organic load, biofilm in that system, we've knocked it loose, we've disrupted it, and we're not going to get it all. And that's why it's so important to make sure there's a sanitizer at a level safe for those birds coming into that post-cleaning water. Flush water lines on a periodic basis if you can. This is a great way to just reduce the load of bacteria in water systems. We were doing an evaluation in a research barn, and it was city water supply, and the water had been sitting dormant for a little while, and there was quite a bit of bacteria in it. So we looked at different products, whether it was hydrogen peroxide, chlorine tablets, analyte system, which is where we make chlorine from salt, trying to find out what the best method was for reducing the bacteria in the water. And frankly, we found that just flushing it with good old plain, high pressure water made as much difference as any of our products did. So just flushing in fresh, clean water can have a very significant impact for the birds. Water sanitation. Chlorine is a great sanitizer, but we have to remember it's not perfect. Okay, we're going to want to target 2 to 4 parts per million free chlorine. But if that's our target, at the same time, we have to understand that it's going to be affected by several factors. pH. The best pH range to get optimal value of our sanitizing efficacy of chlorine is 4 to 7. If we don't have enough concentration, the bacteria is going to get around it. If the water's cold, chlorine's going to lose its effectiveness. If the water's dirty, that's going to get tied up. That dirt's going to tie up that chlorine and lose its effectiveness. Short exposure time. We know for the most part, chlorine needs about 15, 30 minutes, maybe even an hour of exposure time to really give us full benefits. Growth stage and type of bacteria present. Again, the more biofilm we have present, the more that is going to be diminishing the value of our chlorine. Age and storage conditions of bleach. These are huge impacts on how well chlorine works as a sanitizer. So sometimes I hear people tell me, well, chlorine's not working for us. I think it's more about what we've abused and misused the chlorine products, and that just results in opportunistic organisms taking advantage of the situation. So I've recommended 2 to 4 parts per million free chlorine, but the next question I always get asked is, well, how much chlorine is too much? The better question we need to be asking is, how much chlorine product, are we putting into the water? Think about it. Common chlorine is stabilized at a pH of 11, and that's going to be sodium hypochlorite, calcium hypochlorite. Both of these products put a bitter taste to the water the birds do not like. So how much free chlorine residual that we can measure without affecting water consumption is going to be dependent on the following. What is the product concentration? Is it a 6% chlorine product versus a 10 or 12% chlorine product? Again, the stronger, the more chlorine in that concentrate, then the less product's going to be required to achieve our free chlorine goals. How has the product been stored? If we've stored that product out in sunlight, or if we've allowed that chlorine solution to be exposed to sunlight, either in a stock solution or through a clear hose, we're going to have a significant loss of chlorine. What's the storage temperature? If products have been allowed to be stored in a hot area during the summer, it's going to damage our chlorine efficacy. So the better questions to ask is, how are we managing our product? How long have we stored them? Are we turning over fresh, more concentrated chlorine products in order to achieve our goals with minimal product so that we don't impact bird consumption? Just a quick note on monitoring water sanitation. A great tool is the oxidation reduction potential, and it just measures the energy in the water in millivolts. And so if there's free chlorine present and the pH is proper, we're going to have a good oxidizing energy. That chlorine's going to be present as hypochlorous acid, and it's got a lot of efficacy to seek out bacteria and kill it. The water's dirty, there's no free chlorine, the energy's going to be low. If you have sulfites in the water, it might even be a negative number. The optimum ORP levels are 650 to 750 millivolts. So I know if I go on a farm and I'm seeing 728 millivolts, I'll drink water. I will drink the water in that cup right now because I know it's safe. And the meter does not need to be standardized like a pH meter. So if you get an ORP meter, don't get the dual pH ORP because then you can't clean the ORP meter. Alternative chlorine or bleach crystals. This is the active ingredient, sodium dichloroestriazonetrione dihydrate. It's a 99%, and it provides about 55% available chlorine. It's kind of an acid to neutral pH stabilized product. And I recommend this when we have waters that are a high pH. So instead of adding more bleach or calcium hypochlorite to a high pH water and making it even worse, in fact, sometimes we have high pH water and we add bleach solutions into the water, we can get crystallizing at the point of the injector because we bump the pH up so high that it creates stalactites, if you will, at the injector point. And we've done a little bit of work with these products. And again, you can see that, the crystals have nice residual efficacy over time, whereas we were slightly losing a little bit of the efficacy of the bleach over time. So good product. It's been widely used in South America, and in the US, it's becoming much more popular too. Chlorine dioxide, it's a strong oxidizer, stronger viricid than chlorine, and it's effective at higher pHs. It's actually more effective at a pH of 8 versus 6. If you have higher pH water, chlorine dioxide might be a better choice for you. Total chlorine dioxide levels that I see out in the field up to about 5 parts per million. Free residual chlorine dioxide 1 to 2 ppms. Monitor the free to make sure that you've got that killing residual present. Chlorine dioxide can be available as ready-to-use products, 5 to 7 solutions of sodium chlorite. You may see where they add a dry acid to a sodium chlorite, add together in a stock solution. They dissolve, blend, and make chlorine dioxide. But the absolute best systems are when we use a liquid sodium chlorite, inject it along with an acid into a mixing chamber, which promotes the mixing of these two chemicals in order to get that conversion to 60 to 80% chlorine dioxide. Liquid inorganic acids are the best activator. Just make sure that they're not contaminated with things like iron that are going to neutralize your chlorine dioxide residual. They're great systems. They tend to be pricey, so give it a good hard thought if you're going to. Hydrogen peroxide, target 50 to 100 parts per million in the drinking water. It's good for surface water cleaning, controls taste issues. You're not going to get the chlorine byproducts, the off flavors if we're trying to clean up surface water supplies. It's also good for neutralizing sulfur. If you've got a water supply that has a lot of sulfur in it, you might want to use this product to oxidize your sulfur first, hydrogen peroxide, and then run it through a filter in order to clean it up, because it takes quite a bit of product to clean up sulfur, and we don't want to over chlorinate, but we're not going to over hydrogen peroxide. It's going to break down to air and water. I am a big fan of stabilized hydrogen products. They tend to last longer in the water supply. So if we're starting a new flock and they're slow to get the water system moving and getting fresh sanitizer coming in to that barn, stabilized hydrogen peroxides can be a great tool for overcoming that. Monitor and document. Consistent monitoring assures sanitizer residual is present. Documentation is essential for correlating performance with water sanitation. So the people that are really taking it serious out there, they're looking at these products that they're using, they're monitoring, they're actually pulling some samples for bacteria counts, correlating it to the residuals to determine, hey, what is the best program for our operation? Filters and injection points, again, just touch on these, monitor the injector area. Is it clean? Again, do they meet demand? Are the filters clean? We're letting a lot of sediment build up in our filter areas. We're inviting microbial growth. And also dirty filters block flow. So keep our injector areas clean, keep our filters clean. It's very important. If you're having to change your filters quite a bit due to mineral buildup, you need to rethink your program and put in a more appropriate filtration system that's going to do a better job of capturing and removing that mineral and maybe even back flushing it into the environment so that it's not trapping it and building it up in your water. Again, sanitation verification, document what works. So along with your monitoring your residual, pull those samples, swabs, drips, go out there and look, see what's going on in that barn. And this is what I see a lot now. At the end of the line, drip samples, no bacteria. So this is just confirmation that the water sanitation program is working and it's effective. The Watkins water recipe. Accept water can create risk for flocks. And accept that water supplies are unique. Every farm has its own unique fingerprint when it comes to a water supply. What's going to be in it and how things might react with that water to either support your performance of your flocks or impair the performance of those flocks. So identify and quantify contaminants, minerals, pH, bacteria, yeast, mold, others if you need to. Prepare then a strategy to reduce, eliminate the challenges. So once we know what we're up against, then it's much easier to create a strategy that's going to manage it effectively without breaking the bank or throwing product away that has no value for us. Use between flock line cleaning to minimize biofilm. And make sure when you minimize that biofilm that you're flushing in good, clean, sanitized water to keep that biofilm from rebuilding during that dormant period before those flocks come in. Use a daily water sanitizer best suited for the operation. Again, compatible with the pH of the water. Easy to use, easy to monitor, cost effective in the scheme of things. Little bit of water sanitation can save us a lot of headaches. Monitor and verify the program works. And what I think is very, very important is when managers believe and support water programs, the team will too. The most effective operations I have visited are the ones where the top managers absolutely had a passion for making sure the water programs were the best that they could be. Thank you very much for your time and attention.
All right, Dr. Susan, that was a very good presentation. Thank you so much. Very clear, very practical. Guys, the Q&A session is open now. So please start posting your questions on you're gonna find on the bottom part of the screen, your Q&A button. We ask you to avoid posting questions on the chat so we can follow up on the questions and see what is answered and not answered. So while we are waiting for some questions here, Dr. Susan, we have one question that came through email here that is to expand a little bit more about UV water treatment versus ozone water treatment and chlorine water treatment. So what do you, if you can expand a little bit more about the topic. Thank you.
Okay. That's a really good question, Victor. So UV light, you basically pass the water through a water stream, and the ultraviolet light is going to treat that water. And it's just really important to make sure that that water stream is matched appropriate to the UV bulbs, and that's going to just kill whatever passes through. Now, if you recontaminate that water downstream, you have no effective residual like you would with chlorine to deal with any challenge. So if there's Pseudomonas, things like that downstream, it's going to recontaminate it. Ozone is going to be very similar to UV, except ozone is going to just rip everything apart. If there is any contamination in the water, it's going to just shred it, tear it apart. UV is just going to kill any bacteria. It's dead. It stays whole, moves through the water. UV or ozone is going to rip it apart. Now it's put those nutrients into the water stream, and then ozone's going to hit it, kill it, gone. So it's very much like UV, that it's point of contact, except that it's shredded whatever's in that water and put those nutrients into the water. So again, if we have any recontamination downstream, you've really upped the potential challenges because you've put the nutrients into the water stream. So with ozone, you're going to want to ozone, filter, remove any minerals, any nutrients, and then you're going to want to use a type of sanitizer that'll put a residual in it, your chlorine dioxide, or your stabilized hydrogen peroxides. So again, I missed that part, but I'm pretty sure what I was telling you guys is, if you've got a water system that you know is contaminated coming from the source, there's nothing you can do about it. We just got to live with it. But we're having to vaccinate, use products. Use that UV as your primary to try to get that, continuously keep that contamination minimized. Then use a secondary residual product like chlorine dioxide, stabilized hydrogen peroxide on a continuous basis, unless you have to roll off of it for your vaccination. And not sure I mentioned, but I have some operations that actually use a deactivated carbon filter. So they have their chlorine right up to right before they're going to use their vaccination, put in a deactivated carbon filter, neutralize their chlorine, vaccinate, because now we know we've removed that chlorine that's going to damage the vaccine, do their vaccination process in their minimum window of time, and then pull that filter and then get the chlorinated water back going. I hope that answered the question.
Yes, it answered a lot. And before passing here the moderation of questions and answer to Youssef and Santana, guys, just one topic here that is always asked about the recording of the webinar. It will be available after this. You're going to receive a link for a survey, and after that you're going to have a link to access the webinar, and the webinar also going to be available and posted in our website. Okay, so with this I pass the Q&A to Dr. Youssef and Dr. Santana. Thanks, guys.
Thank you, Vitor, and thank you, Dr. Susan, for that great presentation. We have a question here. Our first question is, what is the difference in using acetic acid and acidifier for water acidification?
So acetic acid is an organic acid. We call it vinegar in the US. And what I have learned about it is acetic acid, it tends to be a weak acid as an organic acid. And if you have a lot of alkalinity, a lot of buffering capacity in that water, it's going to resist that acetic acid lowering the pH. And you may have to put a lot of product in that water to try to get it lowered, and you may start altering the flavor to where the birds are not going to like it as much and still not achieve your lower pH goals. What I have found is acetic acid, some of these weak organic acids, just put it in the water at a level that the birds like to drink. They like low levels of it, and then it's going to help us with those lower gut health challenges, trying to, if the bird's going off feed, that pH is starting to go up in the intestinal tract because they're not eating normally. But if they're still drinking, getting that organic acid, they can kind of keep that intestinal tract pH tempered, so that if we've got Clostridium coming up out of the hindgut, because we know food's going back and forth in that intestinal tract, that Clostridium's coming up out of that hindgut, and we're keeping that pH down, then we can potentially prevent enteritis problems, necrotic enteritis. Not going to promise that, but enough evidence over the years says it does help. If your challenge is to get the pH lowered and you have alkalinity issues, we start getting more than 100 ppms of calcium, magnesium in the water, we've got buffering capacity there. We're going to want to look at more of an inorganic acid blend, maybe something with a little phosphoric acid that's buffered in order to achieve that lower pH. So organic acids, great for gut health, may not be as good at lowering the pH when we have that alkalinity buffer in the water. Inorganic acid's going to do a much better job of lowering that pH, if you will, if we have a pH goal in our water.
Thank you, Dr. Susan. Great answer.
Thank you, Dr. Yeah.
My colleague, Santana, thank you.
Okay. I have some question. This is any suggestion of managing free-range flock that consume dirty water on the range after a period of rain?
A period of rain. So if I understand the question correctly, we've got rain events that are influencing the quality of our water. Is that correct?
Yes, for free range. Yeah. After the free range.
Oh, free range. Okay. Now I'm with you. Sorry. In the US, where we're going free range, and now we're having the spotty liver, the clostridial issues, and they're actually correlating and seeing the Clostridium, or not Clostridium, Campylobacter in these free range water supplies, if you will, surface water supplies in our free range, I'm just heavily encouraged to do what you can to minimize that water. And I think, okay, so we've got these rain events, we've got these puddles, we're going to pray that the sun comes out. Sun's going to help us to some degree have some antimicrobial activities on these surface water supplies. But I think if birds do get contaminated and then they go inside and then they contaminate our water lines in the barns, there I think maybe a big part of our challenge is bringing that contamination to a water system that's going to be a lot more vulnerable to harbor and keep giving the gift that you don't want to keep giving. So minimize what you can on the free range for water supplies. Maybe even if you've got some water supplies where you can, you on surface water supplies where you mix up some stabilized hydrogen peroxide and just give a little splash into these water puddles if you can, and then make sure after you've got these surface water supplies birds are drinking that your water systems in the barns are effectively sanitized so that we don't get those systems contaminated and then they just continue to re-give these Campylobacter challenges.
Okay. Thank you, Dr.
Susan.
Another question we have is, what is the effectiveness of triple salt through water for control of viral challenges?
Triple FOS. I don't know if I'm.
Triple salt.
Give me some more clues on what that is. What would be the key ingredient in triple FOS?
I've never heard of that. So
I'm with you. Thank you, Youssef. You guys have given. I always get questions that I can't answer, so I'm sorry I'm not the perfect expert here. If they can give you some ideas, let me know what the chemicals are on those, then we can address that.
Yeah, so we'll move on to another question. Is there a possibility of reduction of excess minerals in water if prolonged usage of ozonation practice or of using ozone practice?
See, I don't see ozone as it's going to help some with oxidizing iron and manganese. It's probably not going to be as excellent as your chlorine and your chlorine dioxide are for iron and manganese. I do not see ozone being effective against calcium, magnesium, hardness minerals. That those really need an ion exchange of sodium for the calcium, magnesium, or what some people do is we just use what's called a sequestering agent. A buffered phosphoric acid is typically the ones that they use. And we want to use a polyphosphate, not an orthophosphate. So ortho will drop the pH too much and damage your pipes. So we either need to just get it down to pH around 5 with the buffered product so it's not damaging the equipment, to keep it in solution. Just get those calcium to the birds, helps your eggshells, or do a salt exchange, a water softener. But ozone's not going to remove calcium, magnesium. Will do with the iron and manganese. You just got to have a filter after you ozonate it in order to capture those minerals and not let them just be settling out downstream.
Thank you, Doctor. Dr. Santana?
Okay, thank you, sir. I've got some question here about the frequency of the water sample. To take the sample to test the chemical and microbial analysis, how many times that you recommend, Dr. Susan?
That's a great question. So I would encourage you, as you're starting your sanitation program, I would almost be encouraging you test daily for your residual, just to kind of get a feel for how much variation with the product I'm using, with my water supply, is showing up, and try to do it on a consistent basis. Maybe first thing every morning, or sometimes maybe you want to even just randomly check a couple of times a week in the afternoon. Is it falling off? Then for your microbial sampling, I would do that as I'm setting my program up, maybe once a week, once every 2 weeks, to go, okay, I'm seeing this consistent residual. All right, what's it actually doing to the microbial challenge? And then once you get your system set up, then I would be encouraging you to do it a couple of times a week, your residual. If you know you're consistently doing the same thing, your team is, a couple of times a week, and then maybe once every couple of months, you pull a sample. Don't even worry about it being sterile. You just go in there with a Whirlpack bag, take a sample out of a cup. If there is sanitizer in that water, there should be no bacteria, irregardless of how you pull the sample.
Thank you,
Good
Doctor.
answer. Thank you, Dr. Susan.
We have another question. Can NADDC, potassium monopersulfate, in combination of water acidifiers at triple dosing, be used as an effective pipeline cleaner and descaling agent? If yes, please let me know about its efficacy.
And that's another one that I'm not as familiar with, but I'm familiar with some of the chemicals in there. And I would say it probably would be. I would hope it is just verify that that product is a buffered acid. And what you're going to shoot for is you just want to get your pH below 5. And I would recommend, I wouldn't be leaving it more than 24 hours. We don't want to be damaging that equipment. So I'm not going to promise you that's the ideal product to use because I'm not as familiar with it. But I would say, and here's just what you can do is if you're ever working on a water system and you find that pipe that's got some calcium in it, cut a piece out, drop it in a bucket with some of that product, see what happens overnight. And if it dissolves it out, you'll know you've got the product that you need. But I would say probably you're on the right track with what you're wanting to do there. Something I didn't mention earlier, if you descale with your acid products, after you descale and you're flushing in good clean water, put a few drops of dishwashing soap. One that's popular in the US is Dawn dish soap. Put a few drops of that in your solution, your medicator bucket water, and just let that little bit of soapy water, just a hint, go into that system. That's going to help lubricate those drinkers to help them work well after we've done that descaling, that demineralizing of the water system. How's that for not answering your question?
Thank you, Doctor. Dr. Santana, please.
Thank you, Dr. Yusuf. And for chlorine, how many ppm is good for drinking water? And how much chlorine? How good chlorine to remove the biofilm?
So chlorine is not going to do a good job of removing biofilm. We really have to rely on things like the stabilized hydrogen peroxides and get those 3% concentrations or whatever recommended concentration the manufacturer recommends. I've actually seen some people use them. I'm not recommending this. I'm just saying I've seen it used. I've seen some formaldehyde products used in water systems. Virkon can be an excellent type of product to remove biofilm. You're just going to have to follow what is labeled for use in your areas, but don't rely on chlorine as your biofilm remover. That's just not its job. It's going to take care of whatever gets released out of the biofilm into the water stream. That's where it comes in handy. And then at that rate, I'm going to stick with, you want about 2 to 4 parts per million free chlorine. And again, if we're managing that chlorine product properly, if we've got a chlorine product that has good residual, maybe 12% versus a 6%, then we're going to be able to have good results with a 2 to 4 parts per million free chlorine. Now, with that said, there are going to be times maybe we need to bump that chlorine up. And again, there was a new farm very recently, breeders, and the service tech went in and they were measuring like 8 to 10 parts per million free chlorines. The birds could care less. It was a brand new farm, brand new chlorine product, brand new system. So there wasn't a lot of things that were tying up that chlorine to where we were adding more chlorine, but you know, we weren't measuring it, but it was tying up the, you know, but we were putting a lot of those chemicals that come along with chlorine that make the water bitter. 8 to 10 parts per million chlorine, the birds could care less. They were happy as a lark. Now we could turn around and we could be on an older operation and we could have 8 to 10 parts per million chlorine, but it maybe we're having to add a lot of chlorine because there's a lot of biofilm, that chlorine's getting chewed up. And that same amount of chlorine, 8 to 10 parts per million, could be backing the birds off because we're putting that bitterness in the water they don't like. And then we get so focused on measuring chlorine residual, we're not paying attention to what our product's doing to the taste of water. I was on a turkey farm a few years ago down in South America, and the birds were beautiful, but they would not, that farm could not make weight. And they had open troughs. And so I just went over and I felt the trough and it was just squeaky clean. And I said, okay, they got some chlorine in this water. It's not gonna hurt me to taste it. And I just reached down and tasted that water. It was so bitter because they had so much the calcium hypochlorite product in the water that the birds were drinking as minimal as they can. And let me tell you, if a layer is not drinking the water, you're not going to get very many eggs out of her.
Okay, it's clear enough. So chlorine is not good for remove the biofilm, right?
Not a biofilm remover, great daily sanitizer, just manage it so that you can get the most value out of smaller amounts of product.
Okay, thank you, Dr. Susan.
Another question is, thanks, doctor. How will you identify between total chlorine and residual chlorine?
Free chlorine, that's a good question. So there are test kits available that will do that for you. You pull test strips, just little strips, and I think I have some in my bag here. I'll pull them out. Or actually, I showed you some. We'll do it, and that's a good start. It's not the best way. There's some wonderful little electronic kits. HACH has a good test kits. Lots of options there for just go online, look for free versus total. And it doesn't hurt to test total. So then you can kind of find out, are these two numbers, free and total, close, or are they far apart? What's going on here that might be chewing up my chlorine and giving me minimal residual for my product that I'm putting in?
Okay, looks like we lost Yusuf and Santana. You guys still there?
Yes.
Okay, we also have
Yeah,
some.
my internet connection. Sorry, guys. Thank you,
Okay,
doctor.
please.
Still on question?
Yes.
Yeah. Another question is, does chlorine dioxide performance affect water TDS levels?
Say that again, Yusuf.
Does chlorine dioxide performance affect the water TDS levels?
The TDS, the pH or the TDS?
TDS.
TDS, total dissolved solids. So chlorine dioxide is going to be very similar to chlorine in that it can impact your manganese, your sulfur, your iron levels. Those three minerals will be oxidized by chlorine dioxide. And then you just need to filter them, or they're just going to be little rocks falling out in your water system. Chlorine dioxide at that pH of 8 is actually going to be much more effective if we have higher pH water and we're not adjusting it down like we're trying to do for chlorine sometimes. It's going to be much more effective, more rapid oxidation of your iron and your manganese versus chlorine at a pH below 7.
Thank you, Doctor. Santana, would like to ask a question?
Okay. I have a question. Can we use hydrogen peroxide 3% in drinking water?
No, not for the birds. Do not use a 3%. Yeah, do not use 3% solution for the birds. It will be disastrous. That is only for line cleaning. And that is why I highly recommend putting like a vaccine dye in the solution. So you know when it's in the line and you know when it's completely out of the line. The 50% stabilized hydrogen peroxide, 20%, the whole range of products. What we're going to do is we're going to mix it, if we want to use it on the birds, to where we're getting that 50 to 80, even up to 100 ppms of residual hydrogen peroxide. So that's going to be more of a solution of, I don't know milliliters, but in the US, we would say 2 to 4 ounces in a gallon of water. I'll let you guys interpret that for your customers. So 2 to 4 ounces of product, gallon of water, that's your stock solution. And we're going to inject that 1 to 128. That's your kind of your target starting point for a drinking water level of hydrogen peroxide.
One more question. What is the best, a simple way to, if we have a problem with the high iron, high ferrum in the water, what is the best simple practice can apply in the farm? Because in Indonesia, some island is very high with the iron in the water, and the quality is not good. The water color is turning orange, yellow to red.
Yeah,
yes, orange.
Red.
Yes.
You know, and again,
what is the simple?
I have seen farms where the water was orange. Birds could care less. But again, it's back to your equipment and what pathogens is that going to promote. So the simplest thing you can do is chlorination and a filter system. And there are just some fantastic. So you have your little barn filters that are clogging probably constantly because of that load. There are some very big, nice filters that have like the capacity of 180 stream filters that are not overly expensive, that you can run it through, capture that iron, and then as you see your pressure gauges on either side of that filter start to build up, you shut your water off, you take the filter off, you clean it, put it back in. And so it'll give you a lot more time before you've got to do something about the filter versus the little small canister filter. So chlorination, filtration is your best bet. And I know it's going to be a challenge for some areas to get that, but just start looking, see what you can find, or maybe even do a sand filter bed if you have to, and chlorinate, run it through a sand filter bed, if you will. It's going to have to be cleaned on occasion, maybe once a year or so, but that just anything chlorinate, give it a little bit of contact time if you can, 15, 30 minutes, run it through a filter. That is your cheapest way to deal with that iron contamination.
Thank you. Filter, chlorinate and filter system. Okay.
Yeah,
thank you,
Dr. Filter.
Okay. Any question more, Joseph?
Yeah, we have a question here. How can we convert hard water to soft water to make it suitable to drink for drinking?
Okay, so you got two choices. You can do a water softener, which is, again, you just take sodium, salt, and then exchange the calcium for salt. So now we're putting salt in the water, so we got to monitor that, and maybe we need to have to adjust the salt level in the diet to kind of compensate if we're starting to bump up the salt in the water a little bit. Or we can just what we call, so we have calcium coming in the water and we use a sequestering agent, and that's just a acid product that just keeps that calcium from sticking in the pipe. There's some technologies out there, some, oh, I've gone blank now. It's, what to say, some electronic technologies, if you will, that supposedly put a vibration, keep it from sticking. Seen mixed successes with those, but before you go and spend $10,000, $20,000 on a technology like that, make sure you do your research. So key thing for calcium, magnesium is water softener, sequestering agent, acids. Those can be very pricey. Maybe you can use them a couple times a week to just kind of keep the mineral dissolve from sticking. And then if you have cool cell pads, very important with that calcium magnesium is monitor that recirculation tank, keep it flushed out, because it can just make a rock wall of your cool cells very quickly with that evaporation of the water, minerals concentrating and just really pushing that pH up in that 9 to 10 range and making that calcium want to stick on those cool cell surfaces.
Thank you, Doctor. We have another question here. What is the ideal pH of drinking water in brooding stage up to 4 weeks of age?
Whatever the birds like. I visit so many operations, and one will tell me, oh my gosh, our perfect pH is 5.7. We get our best performance. And then you go to another area and like, well, if we try to do 5.7, it's a disaster. So my first suggestion is make sure it's good, clean water, that you're not allowing any microbial growth. Then start tinkering with your pH. And I would certainly want to get it in the range close to neutral if you have a lot of alkalinity, kind of, but don't over acidify that water in that goal to get it down. Just get it what you can to where the bird's still, it's palatable, they like it. And taste it. I go on farms and taste it. If it tastes weird to you, it's definitely not going to be acceptable to them. So I'm not a huge fan of lowering the pH. Maybe if you do it for 7 days in the pH of 4, if you can do it successfully with your acid, just to try to get them off to a good start, and then roll it back to whatever natural pH. You guys know better than I do. We've constantly got to weigh cost with performance. So don't let us get too carried away because the salesperson has told you this acid's going to do wonderful things. Maybe it will, maybe it won't. So constantly balance that cost performance, but there's so many operations, they don't do any pH adjustment. Their water pH is in the range of 6.5 to 8. They get great performance. So sanitation, good, clean water should be your first goal. Then tinker with your pH. And again, with your acetic acid, your organic acid, sometimes maybe it's better to not focus so much on pH with those acids as it is to just get a level in the water that they like drinking. So if they're off feed, that water, they're still consuming it, and it can maybe give us those benefits in the lower gut past the gizzard. pH of the gizzard is going to be 3.5. So what are we doing? Yeah, in that bird with lower pH water that is going to the lower gut, organic acids.
Thank you, Doctor. Maybe we have time for one last question. How long does chlorine dioxide and sodium dichlorocyanurate last in water line?
If that water's warm, slow moving, we're probably not going to have it around for more than maybe 4, 6, 8 hours. And that's where I think we get into a lot of trouble with our water systems is the lights go off, the system goes dormant, and that sanitizer starts breaking down. And so in the wee hours of the morning, if there's a biofilm, things are going to start coming out because the sanitizer is no longer present. So that's why I love the stabilized hydrogen peroxides when you got low flows. So I wouldn't, now if the system is pristine, they're moving that water, golly, you should continuously have good sanitizer levels in that water from your stock solution if you've managed it properly. Again, I have avoided answering the question, but that's just tricky to know exactly how long, but expect it to not last more than 4 to 6 hours before it's going to be breaking down, whether it's chlorine, the triazonatrione, or the other forms of chlorine and chlorine dioxide.
Very nice, Dr. Susan. Thank you very much for the answers. I see we still have a lot of questions coming in. Unfortunately, we get into the limit of our time here, guys. The questions that were not answered live, we're gonna email to Dr. Susan so she can type back the answers, and we're gonna have all of these answers back. Dr. Susan, one last trick question from my side. And it's impressive how people underestimate the value and the importance of the most important nutrient, that's water, for sure. And with all your experience and all your field visits, if you can define the most common error or key point that you would recommend when it's about water quality, if you can choose one take-home message here for everything that we have discussed today, what would be this point?
Water sanitation. Have a decent water sanitation program. I think that's where we drop the ball the most on the operations I visited. They're going to be tolerant of most of the minerals and things, but water sanitation. We can get them, have good clean water protected as much of the time as we can. We're going to be on the right side of things in our operations.
Wonderful. And I imagine this is a common question because it was really fast. So thank you so much for that. I appreciate your time, your presentation, your availability for questions and answers. Thank you, Santana, Youssef for the Q&A, Katie for all the organization, but especially to all our attendees here, guys. Thank you so much for help us making this happen. And I see all of you in our next round of webinars on the following month. Thank you so much. And with this, Daniel, we finish this webinar, correct?
Exactly, it's correct, Victor. Thank you, Dr. Susan. And we can see a couple hours.
All right,
guys. Today.
Thank you. Thank you, everyone.
All right.
Bye-bye.
Thank you.
Bye, everyone.
Bye.
Thank you.